All right, so we'll begin with problem number one on the study sheet. In this case here, we're going to be using the properties of logarithms to expand each logarithmic expression as much as possible. And where possible, evaluate logarithmic expressions without using a calculator. So in this case here, for problem number one, we have log to the base 8 of 13 times 7. Log to the base 8 of 13 times 7. And we want to expand this as far as we possibly can. So in this case here, if we have the log of a product, then what rule can I use here? The product rule. This is 13 times 7 with the log to the base 8. That means I have to expand using the product rule by writing it as the sum of the individual logarithms. So log to the base 8 of 13 times 7 would just be this, log to the base 8 of the first number, which is 13, plus log to the base 8 of the second number, which is 7. And I will go no further than that because I cannot find a whole number where 8 to what power gives me 13, nor can I find 8 to what power or what whole number power would give you 7. Okay. Any questions about problem number one? All right, number two is the natural logarithm of e to the fourth divided by 8. Natural logarithm of e to the fourth divided by 8. And I want to expand this expression as far as possible. So what rule can I use here? This time the quotient rule, because notice I have a numerator and a denominator, so that tells me I have a natural log of the quotient, so I can apply the quotient rule by expanding it as a difference of their individual logarithm. So ln of e to the fourth divided by 8 will be ln of the numerator, e to the fourth, minus ln of 8. Now, in this case, I'm not done yet because I can do something with that ln of e to the fourth. Because of the fact that if I have ln of e to whatever that exponent is, it's going to be that exponent. So ln of e to the fourth will be 4. So I have 4 minus ln of 8. So sometimes you may have to use one of those inverse properties for common logarithms and for natural logarithms as well. Okay. Questions on problem number two. Number three, we have log of to the negative 6 power. Log of n to the negative 6 power. So what rule can I use here? I got an exponent, so I have to use the power rule. So that negative 6, bring that up in front of log of n. So log of n to the negative 6 power would be negative 6 times the log of n. Okay. Questions on problem number three. All right, number four. Let's say we had something like this, log to the base 8 of 64 divided by the square root of x plus 1. Say I want to expand this expression as far as possible. All right, so to begin with, what rule can I use here? Quotient rule, because notice I have a numerator and a denominator, for my logarithm. So I have the log of the quotient. I can use the quotient rule and expand that as a difference of their individual logarithms. So we'll expand this as log to the base 8 of the numerator, that's 64, minus log to the base 8 of the denominator, that's the square root of x plus 1. I'm going to do something with that square root of x plus 1. That square root of x plus 1 can be written in its equivalent exponential form. And that can be as x plus 1 raised to what power? That be to the 1/2 power because the square root in exponential form, 1/2. Okay. And let me go ahead and evaluate log to the base 8 of 64. What log to the base 8 of 64 means is this. 8 to what power gives you 64? Has to be 2. Because if you think about it, 8 to the second does give you 64. So log to the base 8 of 64 is 2. Anytime you're finding the log of something, you're finding out what that exponent is. So it'll be 2 minus, oh, let's simplify that. What rule can I use there? For that log to the base 8 of x plus 1 to the 1/2 power. What rule can I use there? Notice I had the exponent of 1/2, so I need to use the power rule by bringing the 1/2 in front of log to the base 8 of x plus 1. And here I will go no further than that. So the final answer or the final expression would be 2 minus 1/2 log to the base 8 of the quantity x plus 1. Are there any questions about problem number 4? Now in problem number 5, we're to use the properties of logarithms to condense the logarithmic expression, which is 5, ln of the quantity x minus 9 minus 2, ln of 9. And then we're going to write the expression as a single logarithm. Expression is 1. Okay? And whenever possible, we're going to evaluate the logarithmic expression without the use of the calculator. So if we have 5 ln of the quantity x minus 9 minus 2 ln of y, our coefficients need to be 1. So the rule that we're going to have to use here is the power rule. That means that these coefficients will be your exponents. So here that 5 will be the exponent for the x minus 9. So I'm going to write that as ln of the quantity x minus 9 raised to the 5th power. Minus, and this 2 would be your exponent for the y. So it'll be ln of y squared. Everyone see that? Here I'm just going backwards here. All coefficients there have to have a coefficient of 1, so you must use the power rule first, and then use either the product or the quotient rule. What rule can I use here? Quotient, because notice I have a minus sign between the natural logarithms. I have the difference of the natural logarithms. I can write that as the natural log of the quotient. So it'll be ln of, here I'm going to use brackets, x minus 9, that quantity is to the 5th, divided by y squared. Okay. Are there any questions about problem number 5? All right, number 6. We're going to use common logarithms or natural logarithms and a calculator to evaluate log to the base 14 of 87.5. And we're going to round to 4 decimal places. So in this case here, we're going to use that change of base property. If you recall, for your change of base property, if you want to use common logarithms, it will be the log of this number itself, 87.5, divided by the log of the base, which is 14. And here we're using common logarithms here. You can also use natural logarithms by saying ln of 87.5 divided by ln of 14. All right, so using a calculator, we press the log key or the ln key, whichever you're using, and then 87.5, close parentheses. Then that's going to be divided by, press the log key or the ln key, 14, close parentheses. So the 4 decimal places, what would this amount be? Okay, 1.6944. So that's what log to the base 14 of 87.5 will be, 1.6944. Okay. Any questions on problem number 6? So those first 6 problems came from section 4.3 dealing with properties of logarithms. All right, 4.4, well, problems 7, 8, 9, and 10 are from section 4.4, and also problem 11 from 4.4 dealing with exponential and logarithmic equations. So in problem number 7, here we're going to solve the exponential equation 3 to the 2x plus 1 equals 27. And you're told to solve this by expressing each side as a power of the same base and then equating the exponent. So you're told what to do there in that problem. Okay, so the left side, we already got 3 to some power, 2x plus 1. But we need to write 27 as a power of 3. Now, of course, you can do that by dividing 3 into 27. That's going to go 9 times, and then 3 goes into 9, 3 times, 3 goes into itself 1 times. And how many factors of 3 do I have here? 3. So 27 can be written as 3 to the 3rd power. So in this case here, these bases are the same. That means I can set the exponent on the left equal to the exponent on the right. So I can set 2x plus 1 to be equal to 3. And from here, we'll just solve the equation for x. So if I subtract 1 on both sides, that means 2x is equal to 2. Divide both sides by 2, you'll get x is equal to 1. Now, you could check this if you had the time to do so, but I don't think that's required for these exponential equations. So here, x equals 1 is the solution to that exponential equation. Okay. Are there any questions about problem number 7? All right, problem number 8. Here we're going to solve the exponential equation 3 e to the 5x equals 1977. I'm going to write the solution set in terms of natural logarithms and then use a calculator to obtain the decimal approximation to 2 decimal places for that solution. So the first thing we need to do here is get the exponential expression e to the 5x by itself. Here we're multiplying it by 3, so the opposite of that would be to divide both sides of this equation by 3. So now you got e to the 5x equals to, what's 1977 divided by 3? 659. So e to the 5x is equal to 659. Now, since that exponential expression is by itself, the next step would be to take the natural logarithm on both sides. Okay? Now, if it was had a base of 10, then you'll take the common logarithm on both sides. But for e and any other base other than 10, you'll have to take the natural log on both sides. Then on the left side, we have to use one of those inverse properties for natural logarithms. If you have the natural log of e to whatever your exponent is, it's going to be that exponent. So what's ln of e to the 5x? Just 5x equals ln of 659. And then to get x by itself, we will divide both sides by 5. So x is equal to ln of 659 divided by 5. This represents the exact value. Okay. Sure, in the homework for section 4.4, you were required to give the exact value, and this would be it. And also, you're required to give the approximate value. Okay. So this is where we use our calculator. Let's see. We press the ln key and then 659. You want to close the parentheses around 659. Because whatever ln of 659 is, you're going to divide that by 5 and then hit enter. Now, what would this value be to 2 decimal places? .30. Because here, the second number after the decimal point is a 9. To the right of it is 8. That's bigger than 5. So 29 will go up to 30. So it'll be 1.30 for the approximate value of x. Are there any questions about problem number 8? All right, now problems 9 and 10 are logarithmic equations. Now, keep in mind that with these, you are required to check your proposed solutions as well as solve these equations. Okay, because what you want to do is reject any value of x that would give you a log of a negative number or log of 0. So in problem number 9, we got log to the base 2 of the quantity x plus 2. To the base 2 of the quantity x plus 2 minus log to the base 2 of 7 is equal to 3. Okay, now, first things first, you want to make sure that each side of the equation is a single logarithm. We don't have a logarithm on this side here, but on the left side we do. But we want it as a single logarithm. So what rule do I need to use here to condense this? Notice the minus sign, we have a quotient rule that we need to use here. The difference of the individual logarithms condenses as the log of the quotient. So log to the base 2 of x plus 2 minus log to the base 2 of 7 will be this. Log to the base 2 of x plus 2, that's your numerator, divided by 7, that will be your denominator, and then that's equal to 3. Now, with this problem, we only have the logarithm on one side of the equation. So with this, we're going to have to convert that into its equivalent exponential form. Okay, we need to convert that into its equivalent exponential form. So that means here, the subscript for your logarithm, that's your base, which is your 2. What's after this equal sign? That's going to be the exponent for 2. So it'll be 2 to the third, and then that's going to be equal to that x plus 2 divided by 7. Okay, so in its equivalent exponential form, we have 2 to the third is equal to x plus 2 divided by 7. And now let's simplify this. 2 to the third power is what? 8. So I have 8 is equal to x plus 2 divided by 7. So what would be the first thing I need to do here to get x by itself? Multiply both sides of this equation by 7. Okay, so I have 7 times the 8 on the left side, and then that's equal to 7 times the quantity x plus 2 divided by 7. So on the left side, 7 times 8 will be what? 56. And then that's equal to x plus 2, because these 7s divide out. So 56 is equal to x plus 2. And then to solve for x, I need to subtract 2. So that means x is equal to 54. Now that's my proposed solution. With these logarithmic equations, you must do the check. So using the original equation, I'm going to replace the x with my proposed solution of 54. So I have log to the base 2 of 54 plus 2 minus log to the base 2 of 7. That needs to be equal to 3. Okay, now 54 plus 2 will be 56, so it'll be log to the base 2 of 56 minus log to the base 2 of 7. This should equal to 3. And of course, the difference of the individual logarithms will be the log of the quotient. So it'll be log to the base 2 of 56 divided by 7 equals to 3. And what's 56 divided by 7? 8. So it'll be log to the base 2 of 8 equaling to 3. And if I convert that into its equivalent exponential form, it'll be 2 to the third equaling to 8. And of course, 2 to the third is 8. So that checks. So x equals 54 is the solution to that logarithmic equation. Are there any questions about problem number 9? All right, number 10. Here we got log of the quantity 5x plus 1 equaling to the log of 2x plus 3 plus log of 2. Now, unlike number 9, number 10 has logarithms on both sides of the equation. So to start this problem off, I need to make sure that each side of the equation is a single logarithm. Well, the left side is already a single logarithm, so I'll go ahead and bring down that log of 5x plus 1. and that's equal to. This one, I need to condense as a single logarithm using what rule? This time it's the sum of the individual logarithms, so what rule do I need to use here? Is that product rule? I need to write that as the log of. Let's see here. I'm going to pull the 2 out in front. So it'll be 2 times the quantity 2x plus 3. Now notice I have the log on both sides of this equation, and it's actually log to the understood base of what? 10 on both sides. So here I can apply the one-to-one property, and that one-to-one property is this, of course, if log to the base b of m equals log to the base b of n, then I can say that m is equal to n. That's the one-to-one property. So that means here I can take that 5x plus 1, set that equal to 2 times the quantity 2x plus 3. And now we can solve this equation for x. So if I bring down that 5x plus 1 on the left side and distribute the 2 over the 2x plus 3, I would get what? 4x plus 6. And now I need to get all the variable terms on one side and the constant terms on the other side. So to move the 4x over to where that 5x is, I need to subtract 4x. So 5x minus 4x will be just x, and then plus 1 is equal to 6. So I have x plus 1 is equal to 6. And then to get x by itself, I need to subtract 1. So my proposed solution will be x is equal to 5. But with these logarithmic equations, you must do the check. So here, using the original equation, I'm going to replace each x with 5. So I have the log of 5 times x, which is 5, plus 1. And that's equal to the log of 2 times x, which is 5, plus 3, plus the log of 2. Now here, 5 times 5, that's 25. 25 plus 1 would be 26. So I have log of 26 equaling to the log of 2 times 5, which is 10. 10 plus 3 is 13. So I have log of 13 on this side plus the log of 2. Let's see, I'm going to bring down log of 26. Condense the right side of this equation using the product rule. I have the log of 13 times 2. And if I multiply 13 times 2, I will get 26. So I have log of 26 equaling to the log of 26. I would go no further than that, because the left side does equal to the right side. So I can say here that x equals 5 is the solution to that logarithmic equation. All right. Are there any questions about problem number 10? Okay, on the next page is problem number 11. On the back of this sheet is problem number 11. This deals with compound interest problems here. And it does say here, how long will it take for an investment of $2,500 to grow to $5,000 if the annual interest rate is 7% and the interest is compounded continuously? You'll round your answer to one decimal place. Okay. So here's what problem number 11 is, and let's see what we have here. We have a $2,500 investment, so that's what P is. We want it to grow to $5,000, so that's the amount that we want to reach. And the annual interest rate is 7%. What's 7% as a decimal? 0.07. And we are told that the interest is compounded continuously. So that means we have to use that compound interest formula that has the natural base E in it, which is in this case, A is equal to P times to the RT. A is equal to P times E to the RT. And then we go ahead and substitute. So your A is 5,000. That's equal to P, that's 2,500, times E to the R, that's going to be 0.07. T is what we're trying to find. So this is your exponential equation. 5,000 is equal to 2,500 e to the 0.07t. Now we need to get the exponential expression e to the 0.07t by itself. It's being multiplied by 2,500, so we need to divide both sides by 2,500. So 5,000 divided by 2,500 would give us what? 2. So it'll be 2 is equal to e to the 0.07t. Now we have the exponential expression by itself. So since e and ln are inverses of each other, we'll need to take the natural log on both sides. So ln of 0.07t will be what? Right? And then that's equal to ln of 2. Keep in mind that ln and e are inverses, so ln of e to whatever your exponent is that exponent. Now to solve for t, I need to divide by 0.07. The approximation symbol for t, and then type in ln of 2 divided by 0.07. So in the calculator, we'll do ln of 2, close parentheses, divided by 0.07. So to one decimal place, what would this be? 9.9. So it's going to take approximately 9 years, because the time is in years, approximately 9.9 years for a $2,500 investment to grow to $5,000 at a 7% interest rate compounded continuously. All right. Questions on problem number 11. All right, now problem number 12 deals with solving a system of equations in two variables. Now you could use either the substitution method or the addition method to solve that equation in problem 12. So problem number 12 is this. Here we got 3x minus 2y is equal to negative 5. The second equation is 4x plus y is equal to 8. Now, which method would you like to use, substitution or elimination? What was that? Addition? Okay, elimination. Some of y'all call it elimination, as some textbooks say. We can eliminate a y, can we? Because it got a minus and a plus. If I want this y to be 2y, I need to multiply it by what number? By 2. So I'm going to take that second equation and multiply it by 2. And when I do that, I'm going to bring over the 3x minus 2y is equal to negative 5. Then I do 4x times 2, which is 8x, and then y times the 2 will be plus 2y, equaling times 2, which is 16. And then we'll add these two equations together. Okay? So if I add 3x and 8x, I'm going to get 11x. The minus 2y and the plus 2y are gone. Negative 5 plus 16 is 11. So I have 11x equals 11. Now, if I divide both sides by 11, x is equal to what? So I know what x is. Now I need to find out what y is. Now, first equation or the second equation? I'll use that second equation. Because notice I have a 1y there. So I'm going to use the equation 4x plus y is equal to 8. And then substitute the x with 1 in that equation. So it'll be 4 times 1 plus y is equal to 8. And then 4 times 1 will be 4 plus y is equal to 8. And then subtract 4, y is equal to what? Is 4. So here, the solution to that system of equations will be the ordered pair 1, 4. All right. Any questions about problem number 12? Okay. Problem number 13 is a system of equations in 3 variables this time. Now, I would suspect that this is going to take a while for you to work this one out. X minus 3y plus z is equal to 8. 3x plus y minus 2z is equal to negative 2. And 2x plus 4y plus z equals 0. And in this case, we're going to solve the system of equations in 3 variables. Okay, so first of all, we'll label these equations here. That first equation is equation 1. The second one will be equation 2. The last one will be equation 3. All right, so here we're going to pick two equations, two pairs of equations, and for each equation, we're going to try to eliminate the same variable. So we're going to start with what variable can be easily eliminated, the x, the y, or the z? The y, because notice I have a minus y and a plus y. So I'm going to start with equations 1 and 2. Equation 1 is x minus y plus 3z is equal to 8. Equation 2 is 3x plus y minus 2z equaling to negative 2. And I've already got the opposite signs there, so we can just go ahead and directly add those two equations together. X plus 3x will give me minus y and a plus y add to 0. 3z minus 2z will be a plus z. And then 8 minus 2 will be 6. So I have one equation in 2 variables. 4x plus z is equal to 6. And I'm going to label this as equation 4. That would be equation 4. All right, now, Let's pick another pair of equations and eliminate the same variable. We're going to eliminate the y as well. In this one, I picked equations 1 and 3. So here, equation 1 is still that x minus y plus 3z equals to 8. Equation 3 is 2x plus 4y plus z equal to 0. Now, in this case here, I'm going to eliminate the y. But if I want that minus y to be 4y, I need to multiply that equation by what number? Well, it's already negative, just 4, because I got opposite signs already. If they were the same sign, then I would multiply by a negative number. So here, if I do 4 times x, that would be 4x. 4 times a minus y would be minus 4y, plus 3z times 4 will be 12z, is equal to 8 times 4. That's 32. Then I'm going to bring over the 2x plus 4y plus z is equal to 0. Now, when I add those two equations together, 2x and 4x will give me 6x minus 4y and the plus 4y add to 0. They're gone. 12z plus a 1z will be 13z, and that's equal to 32 plus 0, 32. So this equation, 6x plus 13z is equal to 32, would be equation 5. So notice equations 4 and 5 are equations in two variables. So we're going to work with those. So let me rewrite equation 4. 4x plus z is equal to 6. In equation 5, 6x plus 13z equals 32. Now, what variable would you like to eliminate, the x or the z? Let's eliminate the z, because I can make this z 13z by multiplying by what? I have to multiply by negative 13, because they have the same sign. One has to be negative, the other one has to be positive. So I multiply equation 4 by negative 13. And when I do that, here's what I'm going to have. 4x times negative 13 would be negative 52x. The plus z times the negative 13 would be minus 13z equals 6 times negative 13, negative 78. And then 6x plus 13z is equal to 32. Now, if I add negative 52x to 6x, I'm going to get what? Negative 46x, and then minus 13z and the plus 13z, they're gone. And then negative 78 plus 32 would be what? Negative 46? So I have negative 46x is equal to negative 46. And if I divide both sides by negative 46, x will be. So here we know what x is. X is equal to 1. Now we're going to find out what y is by using either equations 4 or 5, because both of those equations are in two variables. So here I'm going to use equation 4. And equation 4 is that 4x plus z is equal to 6. Because notice I have a 1 coefficient for the z. And x is 1, so it'll be 4 times 1 plus z is equal to 6. 4 times 1 would be 4, so I have 4 plus z is equal to 6. So what must z have to be equal to? Has to equal to. And x is 1, z is 2. So I go back to one of the 3 original equations and replace the x and the z to find out what y is. Now, I'm going to use equation 2 because notice that that y has a plus sign in it and it has a 1 coefficient. So in this case, the equation 2 was 3x plus y minus 2z is equal to negative 2. So we substitute the x with the 1, so it'll be 3 times 1 plus y is what we're trying to find, minus 2 times z, which is 2, equals negative 2. Okay. Now 3 times 1 will be 3, plus y, minus 2 times 2, which is 4, equals to negative 2. Now what's 3 minus 4? So it'll be y minus 1 is equal to negative 2. And if I add 1, what must y equal to? Negative 1. Okay? All right. So the solution for this system of linear equations in 3 variables will be an ordered triple. X is 1, y is negative 1, z is 2. All right. And I'll leave the check up to you if you have the time for it. All right, questions on problem number 13. All right, problem number 14 is solving the system by the substitution method. So here you're told what method to use. Does everyone have this? Okay. In problem number 14, we got 2x plus y is is equal to negative 5. And I would use braces here. 2x plus y is equal to negative 5. And then y is equal to x squared plus 6x plus 7. Okay. And what I'm going to do here is write these two equations side by side. Well, if you look at this, if we use the substitution, you can see that y is equal to something. In this case, x squared plus 6x plus 7. So we can go right ahead and use that substitution method by replacing the y in this first equation with that x squared plus 6x plus 7. So that would go here. So that means here I bring down the 2x plus the y will be substituted with that x squared plus 6x plus 7. And then that's equal to negative 5. Now let's combine some like terms on the left-hand side. Let's see, let's bring down the x squared plus 6x first because I want those to be in, actually, I want those to be in descending powers. But what's 2x plus 6x? 8x. So we got x squared plus 8x and then plus 7 equals negative 5. So now we got a quadratic equation. And in this case here, we want a 0 on one side and all the other terms on the left-hand side. So let's move that negative 5 over by adding 5. So here we got x squared plus 8x plus 7 plus 5, that's 12, equal to 0. And in this case here, we're going to factor the left-hand side since it's a quadratic equation. All right, so that x squared breaks up as x and x. Now, what factors of 12 gives me 8x as a middle term? 6 and 2. And they both have to be plus because the middle term is plus and the last term is a plus. So it'll be x plus 6 times x plus 2 is equal to 0. And then we set each binomial factor equal to 0. So this means x plus 6 is equal to 0 or x plus 2 is equal to 0. And if x plus 6 is equal to 0, what must x be equal to? Negative 6. And then for the x plus 2 is equal to 0, what must x have to be equal to here? 2. So I have x equal negative 6 and x equal negative 2. For each of those x values, I need to find out what y is. Well, I've already got the y equal x squared plus 6x plus 7, so let's use that equation to find out what our y values are going to be for each of those x values. So here, let's start with x equal negative 6. And then we're going to substitute each x here with the negative 6. So we're going to have y is equal to x, which is negative 6, and that's squared, plus 6 times x, which is negative 6, plus 7. Now, if we simplify that, square the negative 6, you're going to get 36. Plus 6 times the negative 6 will be minus 36, plus 7. So what must y be equal to here? Just 7, because the 36 minus 36, that's gone. So you're left with y is equal to 7. So we know one of our ordered pairs will be negative 6 and 7. Now for the other ordered pair, when x is negative 2, that's this right here, let's find out what that y value is going to be. So here we're going to replace each x with negative 2, so it'll be y is equal to negative 2 squared plus 6 times negative 2 plus 7. Square negative 2, you're going to get 4, plus 6 and a minus 2 will be minus 12, plus 7. And in this case, it was 4 minus 12 plus 7, negative 1. So here when x is negative 2, the y value will be negative 1. So the other ordered pair would be negative 2, negative 1. So the ordered pairs 6, 7, and negative 2, negative 1 are the two solutions that satisfy that system of nonlinear equations. That's what problem number 14 is, a system of nonlinear equations. Questions on number 14. All right, also number 15 is a system of nonlinear equations as well. And here we're going to solve this by using the addition method. So in this case here, we got x squared minus 4y squared is equal to negative 7. The other equation is 3x squared plus y squared is equal to 31. All right, which variable would you like to eliminate, either the x squared or the y squared? I'll eliminate that y squared because notice I have opposite signs on those y squares. But here I want that y squared to be 4y squared. So what do I need to multiply equation 2 by? 4. So I'm going to multiply this second equation by 4. When I do that, that first equation will remain the same. X squared minus 4y squared is equal to negative 7. Then if I multiply the 4 times the 3x squared, that's going to be 12x squared. 4 times the y squared will be a plus 4y squared, equaling the 4 times 31, that's going to be 124. Now, if I add those two equations together, x squared plus the 12x squared, 13x squared, minus 4y squared and the plus 4y squared, they add to 0. Negative 7 plus 124 will be 117. So I got 13x squared is equal to 117. Now to get x squared by itself, we will divide both sides by 13. So that means x squared is equal to what? 9. Now, to solve for x, we need to do what? Take the square root on both sides and include plus or minus. Anytime you're taking the square root on both sides, you always include that plus or minus symbol. So that means x is equal to plus or minus what? 3. So that means here x is equal to 3 or x equal negative 3. And for each of those x's, we're going to find out what y is. So I'm going to use, let's use equation 2, the second equation. So for x is equal to 3, I'm going to use this equation, 3x squared plus y squared is equal to 31. Replace the x with 3, so it'll be 3 times 3 squared plus y squared is equal to 31. And if you square the 3, you're going to get 9. 9 times the 3 in front will be 27 plus y squared is equal to 31. Then if you subtract 27 on both sides, I need to pull this page up. That would mean y squared is equal to 27 from 31 will be 4. And then if you take the square root on both sides and include that plus or minus symbol, y would be equal to plus or minus 2. So that means for x equal 3, I have positive 2, and also for 3, it'll be negative 2. So I have two ordered pairs there. Now let's deal with x equal negative 3. And I'm going to use that same equation. So if I replace the x with negative 3, that'd be 3 times negative 3, and that's squared, plus y squared is equal to 31. Square the negative 3, you're going to get 9. 9 times that 3 in front will be 27, which is the exact same equation as I had when I substituted the x with positive 3. So I'm going to go through the same procedure. You'll get y squared is equal to just 4. Take the square root on both sides, include the plus or minus symbol. Also, y is equal to plus or minus 2. So that means for x equal negative 3, I'll have positive 2. And then for negative 3, I'll have negative 3. So here I have 4 solutions for this system, or 4 ordered pairs for this system of nonlinear equations. 3, 2, 3, negative 2, negative 3, 2, and negative 3, negative 3. Are there any questions about problem number 15? Or are there any? Plus or minus 3? Oh, I'm sorry, negative 2. Thank you. Just going too fast. Glad you asked. All right, are there any other questions? Oh. What was that again? Okay.